So if you were finding the angle between two vectors, we would take the dot product divided by the magnitude of each.
Yeah.
So we need to do a quick review. If I give you a vector u that has the components 5, -1, and v has the components of -3, 4. Can you find the angle between the vectors u and v? Alright, so what is the dot product between u and v? So when we do the dot, we're multiplying 5 times -3. Was it plus? -1 times 4. We had a -15 plus a -4. We get -19 on the top. Magnitude of each. What is the magnitude of u? Square root of 26. Magnitude of v.
5.
Simply 5. And then a 3, 4, 5 triangle. When we divide these, -19 divided by the square root of 26 times 5, which is almost 5 times 5. So you get a negative fraction that is, I don't have a calculator. 0.74, the inverse cosine. And this one?
Oh, yes.
And the second one? This is the square root of 26, which is just a little bit more than 5. So we got a decimal, -0.745, ... Inverse cosine. And you got what?
138.2 degrees.
They do a little box. Do you know that negative cosines will always be obtuse angles? It'll always be, it's in the second quadrant where cosine is negative. Okay? So if it's negative, it's going to be in the second quadrant, which means it's going to be an obtuse angle. Okay? If cosine is positive, it's going to be an acute angle. If it's 0, it's going to be 1. They put a little box. If the dot product, that's what it is. If the dot product is acute, it's positive, it'll be acute, negative, obtuse. If it's 0, it will be right. All right. Let's move on and talk about when are we going to apply this. Applications. Some of you are in, nobody's, Emily's in physics. Anybody else in physics? France is in physics. Next year.
I was in anatomy and physiology.
The AMP wonders. So, envision two people having a piece of rope, and they're pulling on something, an item that is heavy. Okay? A tree. No, something that they might actually move. What? A refrigerator.
Like an airplane. Have you seen the
And
people who like
Elephant.
strap themselves and they
Dinosaur.
pull airplanes?
Yes. Okay, but I want to tell you, these people that are pulling this are not.
Not like massive bodybuilders.
They're not massive bodybuilders, and they're not the most logical people because they're pulling in different directions. They're not going straight.
You can pull an airplane like that.
They're kind of going not together. Okay. Go with me here. Okay.
It's all imagination.
Okay. So they are pulling, and what we're saying they're pulling is a vector in some direction with some magnitude. Okay.
And find the angle.
And we're going to find how much force that they need.
Force equals
Yes.
mass times acceleration.
To move it where?
To just move it straight forward. So are we going to have a parallelogram? We sure can. So if somebody, okay, they call it the equilibrium. If you're in 7.5, the equilibrium.
Oh, physics.
Okay, we did do you remember the resultant vector? A resultant vector was when we added two vectors. Okay? Sometimes it's necessary to find a vector that will counterbalance the resultant. The opposite vector is called the equilibrium. Do what? We've done the resultant. We've done that one. Okay? So when you're finding the equilibrium, it's the opposite vector from the resultant.
That just means you switch the signs, right?
Mm-hmm.
And
They have a very nice picture.
so if it's positive, it would be negative.
Mm-hmm.
Oh.
So we have two vectors going this way. If we add them together, the resultant vector is going to be somewhere. I thought I changed colors. It's going to be somewhere in the middle this way. Okay? This is the resultant. Okay? From this point, go in the exact opposite direction. The same magnitude is called the equilibrium. Okay? We're going to talk about the force. If the magnitude of an equilibrium forces, now find the magnitude of the equilibrium of forces of 48 newtons and 60 newtons acting on a point P. That, all that's saying is this is, what did I say, 48 and this is 60. That is the force that it's being pulled with. Okay? Acting on a point A. If the angle between the forces is 50 degrees. And find the angle between the equilibrium and the 48-degree newton. So in just a minute, we'll ask you to find something else. So first thing is, can you find the magnitude of the equilibrium vector? Question, will the magnitude of both of these red lines be the exact same?
Yes.
Yes. So can you find the magnitude of this vector? Well, maybe I can. Do I have enough information? Well, I'm going to argue that fact
You do.
because if we were to draw
It would
this vector up here will be 60.
and then the other one would be 40.
This one right here will be 48. It's a parallelogram we just made, correct? find this angle.
Yep.
Because in a parallelogram, the angles that are adjacent to each other must equal 180 degrees. Okay, so this angle, I think, 130. So you have 48, you have 60, you have an angle in between. We are trying to find this resultant vector, the magnitude of it. If I have the magnitude of this, the magnitude of that, will it give me the magnitude, which is just the length? Can we use sine? Do you have an angle that's opposite the triangle?
Yes. 130.
But do you have the side that's opposite that angle?
No.
That's what we're trying to find. But we don't have these angles right here. We don't have those either. We don't know what they are.
Oh, so we don't assume that it cuts in half.
It absolutely does not cut it in half unless it's a rhombus. And I can already tell you it's not a rhombus. Not a rhombus. So,
Oh.
can we
cosine.
solve for x? Law of cosine.
Yes.
X squared equals a squared
48 squared.
plus b squared minus 2ac cosine 130.
Wait, what?
You have a triangle.
What are we doing?
You have a triangle, yes? You know a side, an angle, and a side. You do not know the other length of it. Law of sines, law of cosines, not going away. We're going to apply them. When do we actually need to use it? So this I'm plugging straight into my calculator. I could put it up there, couldn't I? Does your answer have to be more than 48? More than 60? Are you questioning something?
Yes. Do you have to use 130 instead of 50 because
You-
it'd be negative 60?
You have no. We're using 130 because it's the one that's opposite the side we're looking for.
Oh, okay.
Bless you.
Without this number.
Yep. That's fine too. All digits. The exact same.
So did we just find the resultant side?
The length. What does that mean? Because it asked for the magnitude. Is that what you found? What does magnitude mean? No, those are two different things. What does magnitude mean?
It's the length.
It's the length. It's the distance.
Oh, so
We did just find the length or the magnitude of the resultant vector. How many people have an answer?
98.
Do we all get 98? Point
Yeah,
0.
47.
47.
So I subtract.
Wait, did you get 90?
I did. fall straight in. Okay? So, 98 what? What are we saying? Newtons.
Newton.
Now,
Newton. Why? Oh, that
Because
was
it's
force.
magnitude, force.
the force. It's been pulled. 48 newtons were being pulled this direction. 60 newtons were being pulled this direction.
Oh,
That-
so
that-
compared to that. Okay.
Yes. 9,000 is not a good number. And then, but the question was, what is the magnitude of the equilibrium? They will be the same. Why? Because they are opposite vectors. So they have to be the same length.
And
Exactly.
But why is
Magnitude.
vectors
No.
because it's opposite
No.
direction?
But the opposite direction does not mean it's going to be the opposite magnitude.
Oh, it's math.
Okay. The next question in this, it says, find the angle between the equilibrium and the 48 Newton force.
So is this
So where in the world
A?
is this? This was point A. So now what is this angle theta between the equilibrium and the 48 degree, 48 Newton? Do what?
180. The minus
Minus
that.
this little dot right here.
What is that even about?
Oh, we don't, do we?
Wait.
Can you find
Sine.
it?
Something.
So you know this is now 98. And we have a triangle, so if we want this one,
60.
we have opposites, so we need the 60. Sine 130 over 98 equals sine something,
X.
sine question mark, whatever, yeah, over, what do we do, 60?
So we're solving for the dot,
We're solving for the dot,
which will give us that because it has to equal.
and then we'll subtract it from 180, because it wants the outside piece. But we cannot assume the 50 got cut in half, we can't assume it is 2/5 or anything. So you're doing law of sine to find
I thought we just connect those two and make another triangle.
Have we found the magnitude yet?
we did. This was the magnitude.
Is it what you got?
You want to try to
It is.
Yes.
But so the dot, the question mark angle, what did you get?
Oh, you need
What?
to do 180 minus
27.96, yada yada yada. So we're gonna subtract 180 minus that. So the angle theta between the equilibrium and the 48 Newton force was 152 degrees. Yay.
Wait, the angle between 48 and 98 is what?
And the equilibrium was 152.
Oh,
We found this little angle was 27.9
oh,
something.
like I was confused. I was like, how is that 152? I thought it was small.
The outside one. The theta. Question mark was 28. Yeah. The little dot in between. Okay? Now, incline. They talk about the incline, so I'm sure nobody's ever pulled anything uphill. If the world was only just flat,
That would be crazy.
it would be crazy. But I
It would
wouldn't.
be crazy.
I would not ever have to worry about going up a hill and pulling something.
There's no
Walk up-
end.
walk to school uphill both
It would
ways.
actually be quite.
Depressing, is that what you said? Or
What?
No, it would be normal.
Go up one.
it would be normal if it was
Like it's all you have, no.
No, No, if it is, if the
It's
earth,
also-
like, if the earth is flat, where's the end?
Exactly. Where does the water go then?
Yeah.
Like, if it's all flat,
No, it's gonna
where does the water go?
Oh.
It comes back to the
You're going to
rain
heaven.
It soaks in really quick.
Yeah, it comes back to the rain cycle.
Then you never go to the river or the lake,
And also it
Oh,
comes-
ocean.
ocean.
Oh
All
no.
flat. Okay.
No mermaid anymore.
Okay. So now we're gonna go on to somebody. Somebody is pulling a wagon up a ranch. Okay.
Wagon.
There's a wagon.
I like it.
Or one of those your calculators. Somebody left calculators.
No.
All right. Find the force required to keep a 50-pound wagon from sliding down a ramp, inclined at 20 degrees to the horizontal. Assuming that there's no friction. Because if you're in physics, you know there's things such as friction.
Okay.
Like wind resistance.
So there's an incline, and it's only at a 20-degree incline. Okay? At the ramp. And the wagon is on top of the ramp. Do what? Flying.
Yes. They use the full wagon.
Yeah. This is. It's a little red wagon. The picture's a little red wagon.
Real wagon.
We're gonna go on our way and go our way.
I think everybody needs to ride in a wagon sometime in their life. I used to fix that for a wagon ride about once a week.
That's so
By
fun.
who?
Pulled by mules, Mr. Stanley.
Oh.
But he was to stop by. Anybody want to go for a ride? I was with him every time. Like Kyle even, we went on a wagon ride. That's so sweet. Okay. So we are making an assumption they draw this piece of what this. Okay, the wagon we're all going to pretend is here. They draw a nice, beautiful triangle underneath, not drawn to scale exactly like it should have been. Probably, it probably is more like this. But they draw it at a right angle. This right here is the 50. The force that is pulling it, because we're trying to pull it up, is going to be 50 degrees. It also makes a right angle here, which is where I really kind of got off. Okay? And this is under the wheel, the front wheel of our wagon.
It is a triangle.
Mm-hmm. They are making a triangle. Okay? And we are wanting to know this force that's going to make it not roll down the hill. Okay? Which is, they talk about the gravity.
Wait, how do you get a triangle? Like here.
Well, we're going to make it be that way.
I mean this.
Because the
And
force,
how about tiny?
this force right here, is they're talking about is the gravity, the force that's going to pull it there. Okay. Well, we're going to make this red line be parallel.
So you need to have this.
Mm-hmm.
What? Does it make sense? The question only adds 50 pounds wax and incline 10%. So how do you know he used this?
We're going to talk about parallel lines. Okay. And the fact that if these lines are parallel, there's things that we know about the, oh my goodness, alternate interior angles, the corresponding angles, things that are related to each other. So this angle and this angle have to be the same.
Yes. How about
Okay.
tiny?
So why is this one 20? Because once you have 90-degree angles, okay, they're going to be similar triangles. So that means all the angles inside are going to be the same. All triangles that are similar have congruent angles.
Wait, how do you know the answer?
We're talking about parallel lines. We can make angles. Really? It's more like, if you know these are parallel, then you know this angle is equal to that angle. So we have these two angles and these 90-degree angles, and the last angle has to be congruent. So parallel lines, alternate interior angles, must be congruent. Okay? They both are right angles. So if you know two angles of a triangle are congruent, does the third angle have to be congruent with the third of the other one?
Yeah, similar.
Yes. They have to be similar, but the third angle has to be the
By
same.
the length will be the same.
Right. They don't have to be the same. They
Okay.
could be.
Okay.
Alright.
Similarity.
Alright. Emily and I just went through how we know certain things. Okay? There's a force that pulls everyone. It keeps you literally grounded. It's called gravity. Okay? So there's a
According to
force.
Colby, gravity does not exist.
We won't even begin. I've had that conversation a few times.
Wait, what? What?
Gravity doesn't exist.
Gravity doesn't exist.
What do you mean gravity doesn't exist?
It
Don't
doesn't-
ask me. It's not my theory.
It's not mine either,
Like,
it's
I'm just
Colby's.
saying, like,
Want some proof?
Denial doesn't exist.
what?
Or like denial doesn't
Do you
It
know
does.
gravity really is just a theory? Like, there's actually no like full way to 100% prove it. It's still just a theory.
Well, how else are we supposed
What
to
do you mean that?
But like, there's
I mean,
lots of
yeah,
other
like when you drop something, it's gonna go.
yeah.
What if it
But like,
did though? Like just one time you just drop something.
like
Well, if you
scientifically,
do that, then you can say there is no gravity.
Wait, what?
Like when the day someone drops something and it doesn't go, then you can say there's no gravity.
Yeah.
But until then,
Until
I'm
then.
pretty 100% sure that gravity is a proven fact.
How would it not be? Like what else would?
I mean,
it's
down?
just
It's
a
proving
name.
things and not proving
I mean,
things.
like
I mean, yeah, it's a
scientifically, it's
name,
still
but-
called
It's
the
not-
theory of gravity.
What?
But like, it's basically
It's not a theory. It's
mean,
just something with bounds and a name. It's like a tree.
Yeah.
You know? We just name the idea of things falling together.
So does it really
So it's
exist?
not really a theory to be proven. It was already there.
It's somewhere.
And so they just made a name
It
for it.
just is.
Alright.
Just
There-
is, man.
Like just is.
There are certain things they talk about. The 50-pound force coming from here down. They give it letters. We'll go ahead and do the letters just like the book does. This is a B, this is an A, and this is a C. The 50 pounds of force is really is your gravity, because if you're pulling something uphill, that wagon probably doesn't weigh 50 pounds. Probably almost guarantee it doesn't. But the force that you're pulling against is a 50-pound force because you're going uphill and the gravity is wanting to keep it down. Okay? So the sum of the vectors, B to C and A to C, and A to C, it is the sum, that's what it is. It is the sum of the other two vectors. The vector B to C represents the force with which the weight pushes against the ram. Vector B to F, which I did not draw F up here. B to F represents the force that would pull the weight up the ramp. That's where you're trying to go. Since the vectors BF and AC are equal, AC gives us the magnitude of the required force. Okay? Guess what? B to F and A to C are also parallel, which helps us immensely that they're parallel. So if you have parallel lines, you know a lot of things about angles. Number one, alternate interior angles. We can say that's a right angle and that's a right angle.
that's facts.
Okay? If we know this angle here, this can go into this angle here. Yes? Alternate interior angles.
So that's gonna be
Okay? So we can find that angle is 70 degrees. Taylor's already, well, because we know this is 90 and that's 20. So really what helps us, not only is that 70, this up here is 20 degrees. Right? So I have two similar triangles that have 70 degrees, 90 degrees, and 20 degrees. Where am I going to start? 20 degrees, 70 degrees, 90 degrees. Those two green triangles are similar. So,
If those are parallel, then B and A can equal each other, right?
angle B and angle A, yes. This red 70 here,
Yeah.
yes. So that 100%, that is 70 degrees. Yes. So what are we trying to find? We're trying to find A to C. That's going to be our unknown. We have one side length, but we have all the angles. Can we find A to C?
Wait, why do you say ACC?
Well, it really is the same.
Yeah, because we
As
use the
B to
law of
F.
sine.
Why?
Use the law of sine.
We can use the law of sine. Why?
Because you have, since it's like you have one side, but all the angles, so you can
Equals B
do
to
that.
F?
You
Mm-hmm.
Oh, I'm
Because it's the same force, which this is
horrible with this.
technically,
B to F?
it's the same force that's pulling us up. But does everybody know what sine 90 is?
One.
One.
So
So that is x equals. You know, multiplying sine 90 times x is just 1.
so it's just sine 20 times 20, which is 17.101.
We need 17 pounds of force. We'll keep it from rolling down the incline. We have not even pulled it up the incline. Just to keep it from rolling down, we're going to need that much force. 17, I'll just make that LB pounds of force. I think we're done. What? We will do more. I promise.
This is too much. I'm forgetting all the things we've already learned because we've learned so many different rules.
Oh.